All right, let's just get right into it. Mac versus PC. It's probably one of the oldest arguments in tech, right? But today, we're not talking about brand loyalty or, which one looks cooler. We're going to look at this through the eyes of a professional, an engineering professor who needs to pick the absolute best tool for a really demanding and very specific job.
And that really gets to the heart of the matter. You see, on the surface, a top-of-the-line MacBook Pro and a Dell Precision workstation, they might seem pretty similar, especially when you look at the price tag. But are they actually in the same league? Well, the short answer is no, not at all. One is a fantastic, powerful laptop for general use, while the other is a specialized instrument built for a completely different kind of work.
You've really got two totally different design philosophies here. The MacBook Pro, it's optimized for things like creative work and software development, and it all lives beautifully inside that Apple ecosystem. The Dell Precision, though, that's a different beast. It's designed from the ground up for engineers. We're talking simulation, automation, and literally plugging it into other pieces of hardware. They're just built for two different worlds.
Okay, so now that we've kind of set the stage, let's dig into the first, and you could argue the biggest factor in this engineer's choice, the software. This is all about the digital workspace, where the actual work happens.
And boom, right out of the gate, we hit a massive wall. And this isn't just some small inconvenience, it's a fundamental deal breaker. A whole bunch of the core, industry-standard software tools that are completely non-negotiable for an engineer in this field, they just don't run on macOS. Period.
I mean, just take a look at this list. We're talking about heavy hitters like Siemens TIA Portal for industrial automation, SolidWorks for mechanical design, Keel UVision for embedded systems. These aren't just optional apps you can find an alternative for. They are the absolute foundation of the engineering curriculum. If you can't run the software, you can't do the work. It's really as simple as that.
So, software is a huge piece of it. But the story doesn't end there. An engineer's job is constantly jumping between the digital world and the physical one. It's all about connecting that laptop to real, tangible equipment in a lab.
So here's the thing you gotta understand. University labs, industrial labs, they are built on a Windows infrastructure. The programmable logic controllers, the development boards, all the measurement tools, they're all set up expecting to talk to a Windows machine. The drivers, the interface software, it's all designed for that world. Now you might be thinking, well, couldn't you just force a Mac to work? And sure, you could try. But look at the process. You'd have to run a virtual machine, then install Windows inside that, and then just cross your fingers and hope you can wrestle the notoriously difficult USB drivers to work correctly. Every single step adds a new chance for instability, for licensing errors, for data getting corrupted, things you absolutely cannot have happen in the middle of a critical experiment.
And now, look at the alternative. With the Dell workstation, you plug it in, it works. The connection is direct. The drivers are stable because they're officially supported. The whole process is seamless and reliable, which is exactly what you need when you're trying to get serious work done.
Okay, so we've covered the digital tools and the physical lab equipment, but there's a third piece to this puzzle, and it's a vital one: the people. We're talking about the students who are actually there to learn all this stuff.
And when you look at what the students are using, the numbers are just, well, it's not even a contest. Something like 85% of engineering students are on Windows. That's not just a minor trend. That reality creates a standard in the classroom that a professor really has to think about.
I mean, just think about what that means in a practical sense. When the professor and all the students are using the same operating system, everything gets so much easier. The instructions are the same for everybody, troubleshooting is 1,000 times faster, and you don't waste precious class time dealing with weird platform-specific problems. It just makes the whole teaching process way more efficient for everyone.
But this choice isn't just about what's happening in classes today. It's also about what's coming next, about powering the breakthroughs of tomorrow. So let's see how these machines stack up when you push them into advanced research in fields like AI and computer vision.
And this is another massive point of difference. The world of AI, machine learning, all that high-performance computing, it pretty much runs on NVIDIA GPUs and its CUDA platform. That is the industry standard. The Dell Precision supports that whole ecosystem, which unlocks a gigantic library of powerful tools. The MacBook, on the other hand, relies on Apple's own silicon, which is incredibly powerful for sure, but it has way less compatibility with these critical frameworks that researchers and engineers depend on.
So after you weigh all the evidence, from the software to the lab connections to what's happening in the classroom and what's needed for the future, what's the final call?
It really all boils down to these key questions. Does it run the software I absolutely need? Can it connect to the hardware I have to use? Will it make my job as a teacher more effective? Does it fit in with the rest of the infrastructure?
And can it handle the research I want to do next? For this engineer, the answer to every one of those questions pointed clearly in one direction.
And honestly, this quote from the source material just says it all perfectly. This was never about a brand preference. It wasn't about which one looked better. It was a purely technical and academic decision, made by carefully lining up the demands of the job against what the tool could actually do.
And that kind of brings us to the final thought here. Yeah, this case was about an engineer, but the principle behind it applies to literally everyone. It makes you step back from the silly brand wars and ask a much better question. Forget what's popular or what's cool. What is the absolute best, most efficient, most reliable tool for the specific work that you need to get done?